What's the probability that you have a disease if you test positive for that disease? Let's say that a certain test claims to have a false positive rate of 2%. If that test shows a positive result for you, what's the probability that you actually have that disease? Is it 98%? No. But why? 98% is the probability that you would test positive if you actually have that disease. But it's not the probability that you have the disease if you test positive. Let's try to understand that with an example. The false positive rate just means that if the test were to be done on 100 people who don't have the disease, then 2 of them may get a positive result. To help visualize this, I'm going to have a population of 100 people, of which one person actually has the disease. Then we run the test on all 100. The one who really has the disease may or may not get a positive result, and that depends on how much false negatives the test may give, which is a different matter. But for simplicity, we assume that this person tests positive. Now, of the remaining 99, since the test would produce a false positive result for 2% of the population, we can estimate with some reasonable approximation that 2 people who may be perfectly healthy would receive a positive test result falsely. Now, if we were to take these 100 people as a whole, 3 tested positive, but only 1 really has the disease. So in fact, if you had tested positive for the disease, the actual probability that you might have this disease is just 1/3, or close to 33%. This is what Bayes' theorem helps you calculate. In this context, it's the probability that one has the disease given one tests positive. This could be used in any situation to answer similar questions. What's the probability of A given B? Mathematically, this is expressed as probability of A given B equals the probability of B given A multiplied by probability of A divided by probability of B. In our medical test example, this is how this expression is going to look like. The probability that someone has the disease given that someone tests positive is equal to the probability that they test positive given that they have the disease multiplied by the probability that someone has the disease as a whole in the population divided by the probability that someone tests positive. The denominator portion here can be split further into the probability that someone tests positive correctly and the probability that someone tests positive incorrectly. If we substitute the values from our example, we had a true positive rate of 98%. So the probability that someone tests positive if they have the disease is 98%. That is multiplied by the probability that someone has the disease in a given population, which is 1%. This answer is divided by the probability that someone tests positive correctly, which is 0.98 times 0.01, which is the same as the numerator, plus the probability that someone tests positive incorrectly, which is 2% multiplied by 99%. Note that this 2% is the false positive rate and 99% is the population that doesn't have the disease. The result of this expression is 0.33 or 33.3%. Notice how this result is very close to the approximate result we got earlier. And that is a real-world example of application of the Bayes theorem.